So as I mentioned earlier, is going to be like so figuring out like what is that? As I said, right? So I'm planning to go ahead for the outlook with my play golf and temperature with my play golf and humidity combination with play golf. All the combination I'm going to arrive the data, and it's going to be subtracted my the basic entropy. That is nothing but here. So let's taking my examples outlook, sunny, overcast, and rainy. So all this combination, what I'm going to do. So here I have um, outlook, sunny, overdue, and rainy. 1 minute actually. Can you give me just 5 minutes? Actually, I got an email from office. 1 minute. I don't know why they are sending. Okay, high priority. Okay, let me finish this session. Okay, then we'll go ahead. Okay, so here I just have given the combination. For example, I go here, right? So if the combination, it's going to be a different area. So for the outlook, and going to be, yeah, I'll go with this one. The outlook and sunny, I have three yes and three no. So can we go ahead and check that is one. So outlook and sunny, right? And other combination going to be how many yes and how many no. Okay. So here there are lots of coloring. Probably just you go through that. This is a best and universal example for a decision tree, so that it will be easy to understand from you guys. Okay, so it will be easy, not a no big deal. So sunny and what is the combination of this? So play goal. Okay, play right. So how many sunnies here? One, two, three, three, and four. Okay, four things are there. Then I'm going to find out how many yes. One, two, okay, and then where other sunny, yeah, yes, three here. Okay, so let me take this picture so that it would be easy. Front screen, front screen. I'll going back to my this one. Okay, then I can play around here. Yeah, so this sunny and yes, this sunny and this yes, and what else? Sunny, yeah, sunny and yes. So I have one, two, three sunny, right? Three yes. How many no's? I'll take the different color, sunny and no, sunny and no. So totally how many sunnies? One, two, three, four, five. So three yes, two no. So coming back to my calculation, I'm getting three no's, three yes and two no's. The same way for overcast, it's going to be a four yes and three zero no's. And for rainy, going to be a two yes, three no's. So I'm going to apply this one in this formula, the entropy of my target as well as uh, my target, my this is going to be my predictor. My x variable is independent. That's the reason it's in the form of x. Okay, so this is we have the formula called summation of this value. Don't confuse yourself. So we need to apply the entropy of individual value and then subtracting from that from your entropy t. Entropy t is nothing but my already I calculated the value 0.94. So I'm going to calculate this the value with this sunny and overcast and rainy, all the combination for individual calculation, I'm going to get 0.97 and going to be zero value and it's going to be 0.97 something value. So I will use to get this combination value in the form of what is that logically applying this formula I can get it. Don't worry about that. These are the mathematical behind this functionality. If you do that, you can get this kind of structure output. So finally I get it, the gain for outlook, temperature, humidity and wind speed, different values. Based on the calculation, I have arrived a combination of wind display and true or false. And the same way for humidity, high or low, yes or no, we are playing or not. And temperature, hot, mild, cold, we are yes or no and other combination. So same way, I arrived four different gain values. As I mentioned earlier, I'm going to choose the largest information gain as a decision node. That is going to be a my root node. So I'm taking this 2.240, sorry, 0.247 is going to be my root node. So from that, I'm deriving my overall given data set as a sunny, overcast, rainy. So if I get this one, I can have this different data structure. So I can go ahead and proceed my what is that? My analysis. So here clearly mentioned, if outlook is equal to sunny and windy is equal to false, then there is no play. Play yes or no? Yes, combination. And outlook, sunny and wind, true, and play is another combination. The same way, I have a different combination around for this specific outlook parameter as a route and I'm take my decision and I'll proceed on that. Okay, this is a basic example of the decision tree. How we arrived entropy. Entropy is nothing but the final target, and gain information is nothing but my actual parameter and dependency with my target value. So the overall things will be extracted. I mean, subtracted means subtracted by the value. So all the parameters I've taken for my analysis going to be my four parameters going to be outlook, temperature, humidity, and wind speed, all the stuff. And finally, I'm taking the major data, that is the highest one gain, and I'm taking the my route for this one. Okay, this is the simplest way. I'll show the basic the code. Okay, so here it's very simple. Nothing like I think already you guys are like familiar with this all the code, so I don't explain. Straight away you can go ahead. So here decision classifier is one of the what is that the class file we are class we are importing here, and as usual you are trying to split and the matrix I'm doing here. So let me pull out my Excel sheet. Open. Oh, sorry, it's already there. Yeah. Okay, so this is my data set. Okay, so what I'm going to do, this is a Pigma Indians diabetic the prediction data point. So I'm going to predict whether the person going to like have the diabetics or not. Okay, so this is the basic scenario we are going to handle in this uh, by using decision classifier. Okay, so since I don't have a column for this Excel sheet, so I'm making the column for this one. Okay, so the first column going to be, yeah, the pregnant numbers, and then glucose value, BP value, and skin type and insulin level value, and then the BMI and all other the parameters I have. And the last one is going to be my target. That is nothing but my whether they'll have a diabetic or not. Okay, and this is no, you know very well already we have used that one. Actually, even you can have this one as in your header, and so that we can remove this the column. That you know understood. Like so many days actually we are working on this one. and header. It's very simple, and the info, that's fine. And then here, the selected column, I'm going to make as my future analysis, and PIMMA, like it's going to be label is in my target, and this is going to be my target value. That is nothing but either play or not. In the example, actually, we have seen, right? So it's going to be a play or not. That is going to be a zero or combination, and ultimately we are going to give this variable. I think already we have discussed this type of what is that, splitting futures and the target variable. So or else, like, please note down, this is a very, this here also we can do that, the split. That's fine. And then here we have already, right, how to split that train and split and test and train, going to be a 30-70 ratio, and random going to be 1. After that, I am going to apply a very simple decision classifier object I'm creating, CLF, and then I'm going to fit. See, until this one is very easy, but after that we have some accuracy and route node. So I execute that. I'll share this file with you. Okay. So after that splitter, this one I'm going to fit, and I'm going to predict the value. Then the value is going to be, accuracy is going to be a 67 point, sorry, per 16.93, 53 something, 58. I can say it's a 58, 68, something like that. Then after that, what I'm doing, I'm going to making a entropy depth. Entropy depth, initially what I'm doing, without giving any instruction, straight away I'm applying decision classifier, so that the system will take a number of route internally, and it finding some accuracy. This comes under nothing 67 percentage. But when we are declaring a decision tree classifier, it's going to be a maximum depth is going to be a 3, means 3 level up to it will go and analyze and get out the data. Okay, so it will go and make the depth of 3, so that after I'm doing accuracy, I'm finding 77 percentage. So since I'm using entropy concept, I can get my percentage value is 77 percentage. So now it is improved. So how it is improved? Because actually I get it until the entropy of the I'm applying entropy as well as the maximum depth 3. Actually here I try to show some graphical representation, but the system looking some graph. Uh, there is some issues. I don't know. Like, I have installed there some graph to represent this one. So due to that, actually, I'm not able to visualize the graph. So what you guys can do, you can execute the same code. Definitely, you can get the tree structure. Inside the tree structure, you can see that your gain and information, and which factors the system by default it took, and all, everything we can find that. Okay, straightforward methodology. Okay, so until when you are completing this one, after that try to install this package and run this code. You will get very nice tree structure formula for tree structure data point for your this specific data set. Okay, so I'll share with you guys. Gain, entropy has been calculated, how the system internally go and supposed to be top, all the information be captured very perfectly, so you don't bother about that. Okay, so it will create like this picture about that. So this is nothing but your decision tree. So the decision tree here, actually we are created is, and if it is going to be a multiple huge data set, then what we used to do, I'll give a small hit. Okay, so if it is going to be a big data set, it's a random forest, then what I used to do, we can split the data set in a small package, and individual package going to be a data decision tree. This one decision tree, this one decision tree, and this one decision tree, and this one decision tree. Okay. So this is going to be my data set. So what I supposed to do, I will connect my data set. I will split the data set and give some portion to this data decision tree, and for this one and this one and this one. So I need to figure out like how individual data tree is performing, and here I'm going to find out my entropy and my information gain. Okay, for uh, all other individual decision tree model. Okay, so after that, what I will do here, I will get the into my actual the gain value, right? If the gain value is like, for example, if I'm getting the value of gain, it's going to be here. Let's say 2, 3, 2, and 2. So the maximum number of the vote for the gain is equal to 2. So what I will do, I will take, sorry, I will take this 2 and this one as my majority of the output, so that I will consider the gain for the given data set as a 2, and I can proceed my things. So this is nothing but we used to have a what is that? The bagging. So the given data set, I'm going to split in different way, as we discussed very long back, right? So how the randomly selecting. So what I'll make like this way, so that the data might be like I'll across the data like this. So randomly I select, so that this might have some data point, and this might have some set of data point, and there might be some overlap between two different data decision tree, and again this might have some there might be a data might be sitting here as well, here as well, and here as well. So here I'm going to apply the data tree with the different combination of permutation combination, right? Combination of things, so that I will apply the decision tree how we did for this sample program. So each will give the gain of individual train. Then I'm going to make the voting method. So let's say if I'm getting the gain for the DT1, I can say is a DT1 decision tree 1. Uh, this is going to be a decision tree 2. Okay, I'll make this is a decision tree 3, and this is the decision 4. This is my data set. So I'm going to find out my decision tree 1 and decision 3 and 4. Maximum the gain going to be is a 2, so that I'll select 2 and go ahead for my submitting my this is the entire structure. It's so called, 1 minute, this is going to be my what, this is called the system called random forest. Simple. So if you're going to have, this is nothing but a bagging concept, average concepts there, that I don't want to go into detail now, so that actually you don't confuse. So just go through these slides. I'll share quickly with ma'am. Okay, so it will be easy to understand, and try to run this code in our local system, and install this properly this the specific the graphicalization tool. So that will give the proper unfortunately I couldn't get that, so it already installed. If I run this one, it's like a requirements already satisfied, but I'm not able to sense through my where I installed my Anaconda. Okay, I try to change that, but I'm not able to do that. So that's the reason. So just on hold. So, but you can try this one when I share the code with you guys. Okay, but random for us is nothing but giving the data, we need to split this one. For this sample, I'll give the code quickly, like after this today or like tomorrow morning. So you can go ahead with that. And tomorrow's session, so we'll go ahead for the leftover items, um, SVM and dimensional reduction, and then some other scaling up, scaling down, all the concepts quickly. So it will take 10 to 15 minutes each topic. Then I think we have done almost all the topic which we have planning to cover for this program.